viewers. In this video lecture, we are going to see on topic Bayesian networks from the second unit of Artificial Intelligence and Machine Learning. Objectives of studying this topic is to understand about the concepts of Bayesian networks and to understand how Bayesian networks are used to represent the knowledge in artificial intelligence. Network representation of knowledge is used to exhibit the interdependencies which exist between the related piece of knowledge. So actually Bayesian network is a DAG, probabilistic graphical model, that represent a set of random variable and their conditional dependencies through one graph, DAG, directed acyclic graph. The Bayesian network could represent the probabilistic relationship between the diseases and symptoms. Given symptoms, the networks can be used to compute the probabilities of the presence of various diseases. Bayesian networks are DAGs, directed acyclic graphs, whose node represent the random variables on or unobservable quantities. Edges represent the conditional dependencies. The edges will connect the nodes if one node is connected to another node, or if edge is available in between two nodes, means there is a dependency in between the nodes, or there is a dependency in between those variables. Nodes are not connected means the variables are conditionally independent. Each node is associated with the probability function. The input to the particular probability function is the set of values for the node's parent variable. Output is the probability of the variable represented by the node. Network representations depicts the degrees of belief of proportions and the causal dependencies that exist between them. And the Bayesian network is otherwise called as Bayesian belief networks. So here in a network, as we told, there are network of nodes. Each node represents the proportional variables. Nodes represents the proportional variables xi, which were connected by the arcs. So the arcs represent the causal influences or dependencies among the nodes. The strength of the influences are quantified by the conditional probability of each variable. And we could have the formula for the Bayesian networks to represent the causal relationship between the proportional variables. So let us have some variables x1, x2, x3, x4, x5, x6. And the joint probability, we can calculate the joint probability of all the variables, that is p of x1, x2 up to x6 equal to, the joint probability is the product of the conditional probabilities. So let us imagine x1 is depend upon two variables x2 and x3. So when we write the conditional probability of x5, we have to write p of x5 on x1, x2, x3. Similarly, imagine x6 is depend upon only x5. So when we write the conditional probability of x6, we have to write p of x6 on x5. Similarly, we have to multiply all the conditional probabilities of all the variables. So the product of the conditional probability of all the variables will be equal to the joint probability of the variable. And our diagram could be like this. That is, this is our Bayesian network. For this network only, we have written the probability values, probability formula. x1, x2, these are the proportional variables, and the edges in between the variables represent the conditional dependencies in between the variables. And we are going to, in this way, we can calculate the probability of some events with the help of Bayesian networking and Bayesian network formula. Now we are going to see one scenario. Harry installed a new burglar alarm at his home to detect burglary. The alarm reliably responds at detecting a burglary, but also it will produce a sound for some minor earthquakes. Harry has two neighbors, David and Sophia, who have taken a responsibility to inform Harry at work when they hear the alarm. David always calls Harry when he hears the alarm, but sometimes he got confused with the phone ringing and calls at that time also. On the other hand, Sophia likes to listen to high music, so sometimes she misses to hear the alarm. Here we would like to compute the probability of burglary alarm. Problem is, calculate the probability that alarm has sounded, but there is neither a burglary nor an earthquake occurred, and David and Sophia both called the Harry. This is the event. That is, in this event, alarm has sounded, but there is no burglary and no earthquake. And at the same time, David calls Harry, as well as Sophia calls Harry. So we want to calculate the probability of this scenario, this event. So for such problems, we should have the probability table. So let us consider these events with the variable names. For burglary, we can take it as B, earthquake as E, alarm as A, David calls us D, and Sophia calls us S. And as already we have seen the formula for joint probability of all the proportional variables. The joint probability of all the variables in a Bayesian network is equal to the product of the conditional probability of the individual variables. In the same way, we have written the formula for this event, that is P of D, S, A, B, E. That is, David calls, Sophia calls, alarm rings, burglary, earthquake. For all the event, we are calculating the joint probability of all the event, that is P of D, S, A, B, E, which is the product of conditional probability of all the events. And in this diagram, we should have the probability table for all the events with their combinations. Then only we can calculate the probability value of the particular scenario, that is the question asked in the problem. You should have the separate probability table for all the events. For alarm A, for example, 0.94 is the probability of the alarm has sounded. P of true, A equal to true, the probability of A becomes true is 0.94. Similarly, the probability of A become false is 0.606. In this way, we should have the probability value of all the events, and finally, by applying the values in the formula, we want to calculate actually the probability of P of S, D, A, not B, not E. That is, Sophia calls, we want to calculate the probability of the situation. Sophia calls, David calls. Alarm sounds, but no burglary, no earthquake. So we are calculating the P of S, D, A, minus B, minus E. And we have to apply the formula in the same way. That is the product of the conditional probability of the individual events. S, D, S is depends on A. D is depends on the variable A. A is depends on not B and not E. The product, and by applying the values, we are getting on probability value. So this is the probability 0.00068045. This is the probability of our asked scenario. So in such a way, Bayesian network can provide the probability value for some problems in AI. Thank you.